Okay, so in this instance, we're going to do the exponential smoothing, but we're going to use the tool provided by the data analysis toolpath. Okay, now a few things with this little tool. It's firstly, it doesn't optimize. So I generally would do what I did in the last video and use solver to find the best possible value of alpha. Also note if you pass it something called the damping factor. Now the damping factor is not alpha, it's 1 minus alpha. So it's basically how much we weight the previous kind of forecast rather than the previous actual value. So let's just kind of start off with a damping factor of 0.9. The input range is just our data. So here we have like B3 to B20. We select the labels. Now here the output range is, we don't have to drop down like one like the moving average. It's basically the first in the series. Here we're using 4 rather than 3 because the 3 to 20 we had the labels. So 4 is the first data row. And we're going to have the chart output. And you can see here our forecast, because we have this very high alpha, we're basically taking, sorry, we have this very high damping factor with a very low alpha. We've got an alpha of 0.1, so we're taking 0.1 of the last actual value and 0.9 of the previous forecast. So you see we're not trailing the actual data in our forecast very much. But let's like do a second one now. So we're going to say this is damping 0.9, and I'll put there alpha 0.1. And we're going to do a second one, which I'm going to call damping 0.1, alpha 0.9. And, you know, here we should be taking, let me just do that. So here we're going to be taking a very high alpha, so we're taking 0.9 of the previous observation. So we should follow, the forecast should follow the actual quite quickly. So I'll put exponential smoothing, damping 0.9, damping 0.9. I won't. We won't. This is just more work. This is more working about the actual tool, so I won't bother updating the axes or anything. So now let's do damping. Okay, damping. Okay, so now let's do exponential smoothing with a damping factor of 0.1 or an alpha of 0.9, and this time we're just going to do it in the D rather than the C. And you see, as I mentioned, it follows very, very closely. So we've got exponential smoothing, damping equals 0.1. And I'll put alpha 0.9, damping 0.9, alpha 0.1. And then finally, what we'll do, okay, we're going to have to make the plot a little bit bigger. Finally, we'll actually do our optimal value based on our error from the previous. So previously we found the optimal alpha was 0.6364. So it's going to be, let me just think, 0.003636. 0.3636 is going to be my optimal kind of damping value. So let's now go to, so we'll say damping 0.3636, alpha 0.6364. I'm going to have to move this up a little bit. Beautiful. And let's do it again. So we've got data analysis, exponential smoothing, and we're going to put in E, 0.3636. And so this is the parameter we found, which was the best combination in the previous example. And we've got our final chart, which I will move down to the bottom. And I'll move the entire chart, not just the title. And you can see here, this is a combination of the two. We update, but not quite as quickly as the very low damping. So no 0.6, sorry, 6364. 6364. Okay, and that's it. So I showed you how to use the tool. Honestly, you see I've already used basic Excel functions to find the optimal value. But this also is nice because it gives you a little bit of visuals. You can see that when we have a low alpha, we don't update very quickly. With a high alpha, we update quickly. And here we found the optimal value we found last time is kind of intermediate between the two of those. So just finish by making everything Arial and 12. And making that bold. And that's looking very, very good. I guess we should actually just format cells, number, 2 decimal places. Okay, and there we go.